Hey guys. Okay, so it took me a couple of more days to actually get ready to publish this video and the pyRevit 4.5 beta version. I'm going to talk about this in this video. Kind of that I wrote this article that explains all the changes that's been done and all the modifications that you need to do to your own scripts and stuff like that. But I realized as I was writing it, I realized this needs a video, to go through the article and kind of explain what's going on. The first thing that I want to make it clear is that this update is not for everyone. If you are writing scripts for pyRevit and you're using it in your environment, you're developing for it and stuff like that, this is definitely an update for you. You need to look into this. The first part of the article is this: who do I need to install this or not? And I'm explaining if you have developed your own Python scripts, yes, you do need to install this. If you're deploying pyRevit in a company, absolutely don't use this. This is a test version. You should use it on your own machines, on your test machines, development machines, and stuff like that, and try it out and modify your scripts to match the new core. But this is definitely not a final version. So with that clear, I want to quickly jump into kind of like explaining a little bit of overview of what the changes are. I'm going to go to actual Revit right now. So this is the new basically bar for 4.5. There are not really many changes. One of the goals that I have had for this version is to get rid of some of the extra tools and stuff that I had. Like for example, if you remember, we had a series of tools that would work on overriding dimensions and stuff like that. They're all combined into single tools now. So like setting to equal or VIF and stuff like that. They're all became options of the same tool. So these sort of like consolidations help pyRevit to boot up a lot faster. And I'm gonna work on this also over the course of the next couple of weeks that I'm getting ready for the RC version, which is gonna be the release candidate. So I'm gonna combine as much as tools as I can into one and provide options for different sort of like behaviors of the same tool. And you can see like I brought the make pattern tool outside because it's becoming more popular and stuff like that. It makes more sense to be accessible, easily accessible. So there are not really many changes into this. The major changes are that you see that a lot of tools they are disabled when you don't have any selections because they require selection. And I'm putting that context selection inside these tools. So they're not actually working, they're not actually clickable when you don't have any selections. But the moment you have something selected, they actually become active. Um, this is as far as basically basically the tool layout changes go. You would be able to see the version 4.5 beta version listed on the about, and it's running by default. Obviously, it's running in the 2.77 version. So let's talk about the core changes that I've mentioned a couple of times. One of the biggest changes in pyRevit 4.5 is the massive rework that I've done on how it executes scripts and stuff like that on the back end. There were two driving factors for me that I really wanted to do this. One was the memory leak issue that I had with pyRevit, that if you keep using pyRevit for a period of time, it would get slower and it would slow down your Revit and you had to close it and stuff like that. One was that, and the other one was that I really wanted to boost up the speed of executing commands and stuff like this, because previously every time you would click on this tool, it would pyRevit had to create a complete new IronPython engine, run that tool, and then dispose it afterwards. And then the next time you want to run another tool, the whole process would repeat again, which would make it a little bit slower. One of my goals was to make this pyRevit, this set of tools, as close as I can to the speed of the comparable add-ons and stuff like that are written in C#. So that's the real reason behind the invention of this bracket mode. Um, that's one. And the second one was that I really wanted to. I've been getting a lot of like emails and comments and stuff like that about the troubles that people have with compatibility between 277 of pyRevit and the Dynamo. So I really wanted to modify pyRevit's core so it can accept multiple different engine versions. And also there are a couple of other developments that there are sort of like Python implementations for .NET other than IronPython that I really wanted to make pyRevit flexible enough so it can use different engines. So this is towards that goal. The biggest change is the rocket mode, and it would affect a couple of things. I've modified the complete pyRevit core to match this, so there are no troubles. Like you would be able to use rocket mode, and I'll show you how you can activate it. It's actually activated right now in mine, but I'm hoping that in the next version for 4.6, everybody has updated their scripts, and maybe rocket mode will become the default runtime sort of like settings for pyRevit. So let's talk about rocket mode a little bit more. So in the default mode, every time you click on a script, pyRevit creates an IronPython engine, runs that script. All these modules and stuff get imported as they're needed by script. Like if you import OS, if you import sys, import RPW and stuff like that, they all get imported, and the script gets executed. The challenge was that, okay, so when the script was run and everything was fine, it did its job, this IronPython engine would be disposed with everything that's been imported into it. The rocket mode actually, as I explained in the previous video, it reuses that engine. So let's talk about that. Let's say I have a script that I'm running in pyRevit in rocket mode. So the script gets executed. It imports a couple of modules. Let's say OS, sys, maybe something from RPW, something from pyRevit, and maybe even one of your own modules. And when the script finishes its job and ends, this IronPython engine with everything that's imported inside it remains in memory. So the next time that you want to run this script or any other script within the same extension, it actually uses that engine again. So the next time you click on a script, it wants to run the script, but it doesn't really have to go through and find all these files and stuff like that and import all these modules and allocate memory and stuff like this. They're already in there, so the performance boost is massive. It's a lot faster to execute Python scripts this way. There's one challenge. We have been doing something. I have been doing something. Because Python is so simple and you want to write it so quickly and stuff like that, I've been doing something that wasn't really the best practice as far as like writing programs, like writing Python modules. And the biggest trouble is that we have been creating global parameters inside the modules that are sort of like volatile. They're not stateless. Let me give you an example. For example, you wrote your own module. This is your script, and you have written your own module, or let's say RPW on pyRevit or anything like that. And you basically import the document from your module. So we say import, from whatever RPW import. Oh, sorry. From RPW import doc. And it would basically import the doc in your script scope, and you would be using it to do stuff. But this doc parameter they actually imported from RPW or any other module is actually a global parameter inside that module, a global variable. And that means that doc is pointing to one of the documents that's open in Revit session. That's your Revit session. But when this script does its job and ends, this engine remains in memory. And if the person that's using Revit closes that document, this global doc variable that was in the global scope of that module doesn't point to anything anymore. And the challenge is that when the next time you're executing that script, this is standard Python behavior. The global code inside that module doesn't get executed again. So this document doesn't get assigned to a new project, because that's how Python is designed. That's by design. So it's a bad practice to create global parameters that sort of like point to something that could be changed when the program is running. So one of the biggest things for me was to be able to figure out a way that provides sort of like a smart object that you could use in your modules and stuff like that always points to the right active document within the Revit session, whether this engine remains in memory or not. So that's one of the big changes that I really have done. This same scenario could affect a couple of other things as well. Like for example, in your scripts, previously you would say from script utils, import this script. And this script was a global object inside inside the script utils module that would point to the script that's being executed at that point. But when this finishes and you run another script, let's say this is another script inside the same extension, and you would execute that, let me create that script util module, and then this script variable or object that's inside it. This script is still pointing to the previous script that is imported it, because that's global and it doesn't change after you after the module is imported. So one of the biggest tasks for me is that to go through all the pyRevit code and make sure I'm not using any global parameters or variables or objects, anything like that, that points to something that could be, that could change over time of the lifetime of that engine, basically. And I've explained all this stuff in this article. This is one of the main reasons that this article is a bit longer. So I've mentioned, let's go through what's changed. Obviously, I've mentioned the pyRevit rocket mode, that's new. I'm mentioning that this feature is experimental, so this is not something that you should use for like deployment of your tools and stuff like that. Just play with it. I'm hoping that you will like it. It's so much faster. This is my default pyRevit setting. So right now to execute all my scripts and stuff like that, it just completely changes your experience of working with pyRevit. At least that was the case for me. And then one of the biggest changes is that due to the same reasons that we talked about, as far as for being able to use the rocket mode, the Revit utils and the script utils modules don't exist anymore. I've moved this functionality inside pyRevit itself, which I'm really liking it, because it's a lot simpler now, and you don't have to deal with like 3 different modules: one Revit utils, script utils, pyRevit. The script utils, in a previous article that I posted, I explained that script utils was really created to support all these like standard tools that are in pyRevit, the core library. But I've moved all that functionality inside the extension. So like all this functionality that used to exist in the Revit utils are now inside the pyRevit tools. There's a library, as I explained in one of the videos, how to create library extensions or add libraries to your extensions. That's what I've done, like pyRevit tools library. All these functionality has been moved inside that extension itself, because it really belongs to these tools. So these two don't exist anymore, and I explained here. That was a while ago. I posted this in April, and I explained that I'm planning to move adopt Revit Python wrapper more, and kind of like get rid of all these like extra libraries that pyRevit ships with and stuff like that. Just make everything simpler. This article, at the bottom of this article, I'm explaining how you should adjust your scripts to basically use the new pyRevit module. All the core functionality is still the same. The only thing that's different is that how you import those objects from from the modules, because these don't exist anymore. You import it from pyRevit. So the code change is really minimal, and I'll explain that in detail a little bit more. We mentioned pyRevit rocket mode. Just a quick recap. If you want to download, activate the rocket mode, go to settings and go to the bottom of this, the first sort of like expander, and find the development and turn on the rocket mode in here. And I kind of like explain what's going on and what's this feature and stuff like that. Again, it's experimental. Make sure that you don't use it in your production environment. The other one that is new is the pyRevit Dynamo compatibility mode. And as I explained, if you activate this here, and it's again under the first expander under general, if you activate this and reload your pyRevit, well, actually you have to close your Revit and reload it, because it's a completely different engine version that pyRevit has to use. So activate this, save the settings, close Revit, and open it again, and pyRevit will be executed inside the 2.7.3 version, which I'm really hoping would solve a lot of your issues with Dynamo. One of the other big changes is that because of the memory footprint, I'm not running all these tools, the IronPython engine, by default in the full frame mode. For you, this might be a little bit of like sort of an advanced feature for a lot of you, but full frame mode basically provides much bigger frames, stacked frames for all the functions and all the steps that you go through your script. And it would take more memory, and I've been having memory leak issues with that. So I'm not using that as the default anymore. This really shouldn't affect any of your use unless you're using like very specific, you're using like very specific things in, using the inspect modules in Python and finding, variables in frames and sort of like inspecting those and stuff like that. That would probably break. But for general rules, for the 99% of your script, it shouldn't really affect anything. As an example, one of the modules that doesn't work with the Iron Python without the full frame is the requests module, which is used to send and receive requests from web requests and stuff like that. But there is a very easy way. If your script requires a full frame, just set full frame engine to true inside your script, and when you obviously reload your pyRevit if you're running in a pyRevit session, so it recognizes that that parameter change, and then the next time you run your script, it actually uses a clean engine, complete clean engine, full frame to get everything done. So it's sort of like very easy to implement it if you actually need it. I'm using a couple more, shipping a couple more useful modules with pyRevit now. One of them is requests. We found actually Guy, my friend, the developer developer and maintainer of Revit Python wrapper. He actually found the exact version of the requests module that works with the Iron Python. So I'm shipping that in. Where am I? Oh, sorry. Bad place. Side packages. I'm actually shipping that and the URL lib3 with the pyRevit, which is going to be useful if you want to make like web requests and stuff like that, or talk to like Revit server and things like this. There's a new user interface feature which I'm calling it like Windows shift click on the tools. So like for example, I have posted a video on how to use the match tool or the let's say make pattern tool. If you hold Windows and Shift and click on one of these tools, you actually see a menu now, a sub-menu now, that you can open the help for that tool, and it takes you to the YouTube channel and the exact YouTube video. It tells you if your script is requesting a clean engine or a full frame engine, as I explained, and then it lets you copy script path, the alternate script path, the bundle path, the unique ID of that tool, and then the sys paths, just to if you want to like test your script to see what's going on and stuff like that. And over time, I'm hoping that I can add more features to this the context menu. But this is very helpful. Everything else that like alt click, shift click, control click, everything else is also in there. The way some of these tools don't have the like if I click on, let's say, I don't know, like this, you won't see that help because the help is not set for it. And the way you do it is that where do I in the article I explain it? I'll get to the bottom of this article and I'll explain to you how you can use. There's a variable like this that says help URL, and you set it to the URL of the page or YouTube video or anywhere that you've placed the help for that tool. And basically, whenever you Windows click on it, Windows Shift click on it, and say open help, it actually opens a website that URL that you have provided. There are two other changes that really doesn't affect you, but they have made pyRevit's installation a little bit simpler. I used to ship all these standard libraries for Python engine in a folder called pylib. That doesn't exist anymore. All of them are zipped and attached to the engine that's running it. So that has made everything simpler. And then the lib folder has been renamed to site packages to match the standard Python naming for the folder that it should include the third-party packages for modules for Python, basically. So inside the pyRevit folder, you will be able to see the pyRevit lib as before. The pylib doesn't exist anymore, and the lib has been renamed to site packages, which I'm shipping all these like third-party modules inside this for ease of use. We talked about the pyRevit mode. It is super fast. I'm really hoping that you like it, and it would actually be useful. So let's talk about what changes you have to make. Obviously, do not use doc or UI doc globally in your modules. You always have to ask for what is the current open document or UI document in your module. So let me give you an example. This should apply to any programming language or anywhere that you're using. It's not really pyRevit dependent or anything else. Let's say this is a module that I'm writing and I'm providing some functionality in this that I'll be calling this action from my script from my pyRevit script to be able to use it. You shouldn't really say, I don't know, from rpw import doc inside the global space of your module. Provide a doc variable parameter for your function, let's say, or elements or element or something, that you basically do this import inside your actual pyRevit script, and then pass that document as a parameter to the function so it can do its job. The beauty of this is that you don't have any global variables in here, and these functions and functionality and everything they provide in a module, they're stateless. They don't care what the document is. They receive the document from the caller, basically, from the script that wants to use it. So make sure you always do that. There are some other like good features about like using elements. Let's say you have an action that you want to pass an element to. If you look into the documentation for elements, like the element class has a parameter, has a property called document. So the element knows about its own document. So you don't have to pass the document and the element to the method or to the module function that you want to use. If you pass the element, then inside this function you can access that document by using element document. Let's say I actually used the wrong name here. So you can say element document and find, what document, if you want to run a transaction or inquire, get some other stuff in that document and stuff like that. That's how you can access it. So this is really how you should write your modules. Don't ever import global documents and stuff like that, global parameters of any kind, like not even like documents that that they're going to change. They might change during the execution during that session of pyRevit or Revit. You shouldn't really use that. The script utils, obviously I mentioned it's gone. A lot of you have been doing this from script utils, import this script, output, linkify, and then pass an element ID to it to get that, the green link that if you click on it would select that element inside Revit. So this output object it still exists. The only thing that has changed is this script, and the script utils don't exist anymore. So this global object don't exist anymore. The way you should do it from now on, and I've explained here, make sure you read all this. You should say from pyRevit import script, and then say output script get output, which this creates the object as necessary for your script, and then output linkify, and then same thing. So all the functionality that's under output, it's still the same. This output object is still the same thing. It's just the way you ask for it that has changed. Same thing applies to the way, for example, you have been using the logger. From script utils import logger. Now you say from pyRevit import script. So instead of script utils, you're importing this script now, and then you ask script for the output here, or for the logger, or for the results, or for the configuration, or for the all the universal data files or the data files that you would require from it. And I've provided like the previous way you would do it or the current way you would do it, and then in version 4.5 this is how you should do it. And then the open URL, if you wanted to open a URL from your script, that's also under the script, and the get information about the project and stuff like that. I'm not sure like how many of you have actually used all the features inside the script utils module, but it was an easy fix for me to go through all my scripts. The hardest part for me was that because there are like a couple of hundred scripts in pyRevit, it took me a while to go through all of them. But the change that you have to do to each one of them is not really that much, and it's mostly like at the top of the script when you import all this stuff, because the functionality of each one of these objects is still the same. Revit utils obviously don't exist anymore. If you used to be doing this from Revit utils import doc, UI doc, blah blah blah, don't use this anymore. Try using RPW, that is shift with the pyRevit right now. Try using that. Get the document UI doc DB and UI from that. Get into the habit of doing this. There's only one catch with this. As I explained, currently RPW hasn't been updated for the Rocket mode. So your script might break if you are sort of like doing this in Rocket mode. What I suggest you doing is that instead of doing this, I'll update this, so I provide this suggestion also. But what I highly suggest you doing is say from RPW import Revit. And then this Revit is an object, you import that, and then you can say, to get the document, anytime you want the document, you can say revit.doc. To get into the habit of using this, because Revit is the instance of Revit that you're running, so it's fixed. The things that are not fixed are like the document or Revit.UI doc and all the other ones. And this Revit, I'll actually show it to you. It's a class inside RPW. So pyRevit, RPW ships with with pyRevit. This Revit script has a class called Revit, and then inside this Revit there is a property called document or UI document. So every time you ask for Revit.doc, it actually executes this command, this statement, asks the UI app for the active UI document, gets the document from it, and returns that to you. So it makes sure that every time you're asking for a document, you get the one that's actually being used right now. Okay, so that's about it. That's that. I showed this to you. So try to get into habit of using that. I'll actually update this before I actually finally post it to the website. Some of you may say, okay, I don't care about the rocket mode. I'm fine with the way things are. You still have to do these changes because the core has changed. But if you don't want to use the rocket mode, you can always, basically there are two ways you can do this. Because rocket mode reuses engine, you can say that I do not want to ever use a reused engine. I always want my script to use a fresh engine. So make sure you say clean engine true. You set it to true inside your script, and that basically gives you a fresh engine every time you run it. And one of the things that I showed you on the Windows shift click on this is that it tells you if your script is requesting a clean engine or not. So that's really that setting. So you can set it that. Or you can go inside the extension JSON definition file that you have for your custom extension and set the rocket mode compatibility compatible to false. If that's the case, pyRevit will not ever use a reused engine for your extension. So all the tools inside your extension will be safe. You don't have to go and set this on all the tools. You just set it on your extension, and pyRevit won't use the rocket mode on your extension. If you actually go, I'm going to open the extension JSON file that I have for the pyRevit modules itself, and you can see that the rocket mode compatibility has been set to true for all of them. And we talked about the bin shift. The help URL that I talked to you about, that I mentioned, is this open help. This depends on availability of this variable inside your script. So if you define help URL and set it to any link, any URL that points to somewhere on the web that has the instructions for your tool, you can absolutely use that and set it, and then you'll be able to see people will be able to Windows shift click on the tool and open the URL. So the installer has been placed. I've provided a link at the bottom of this article. If you go on the pyRevit repository, go under releases, and there's a pre-release for pyRevit version 4.5. The installer is here. It actually doesn't install the master branch. There's a separate branch that's called the release for version 4.5 beta. So it installs that for you. That's why there's a custom installer. It installs it in a completely different folder. So I think I have it already installed. Oh no, this is a different machine. But it doesn't. The installation folder won't be the pyRevit version 4. It would be pyRevit version 4.5. So it won't overwrite the installation that you have. But make sure you don't install it on your actual machines. Just this is only a test version. Some of you might have noticed on the pyRevit repository that I have a lot more releases. This is the way pyRevit, the GitHub works, that it sort of like shows all the tags that I have in the repository as releases in here. I think they're working on like removing this thing in here, but it really, yeah, there are not 22 releases for pyRevit. So it's this one is the pre-release, and then if you go next, the previous one is the standard 4.4 that everybody is on right now. So that's and then that's almost everything I wanted to talk about on this article. So make sure I'll post this video, I'll place this video on top of this article, so you'll be able to sort of like follow through it as I'm talking about this stuff. Make sure you look at all these examples, start modifying your script, test out the rocket mode, and give me feedbacks. Obviously, again, this is a beta version, so there would be like, I don't know, some of the tools might, break and stuff like this. So just let me know about all the issues, and I'll keep fixing it. And as I mentioned before about the plan, we are right now here. So I'm issuing the 4.5 beta right now. I'll be working on improving the tools and getting rid of the sort of like fixing all the issues that have been reported, and the tools that have been requested and stuff like that for the next couple of weeks. And one of the other things that I want to do is that I want to improve the load time of pyRevit, so I'll work on those stuff. And then in a couple of weeks, we'll see the 4.5 release candidate, which would be a much more stable version of pyRevit. Hopefully by that time I'll get your comments back also, and then we work through the I'll work through the clean up the code and provide the documentation for the full 4.5 version. I really appreciate all your support, and let me know in the comments, or if you want to email me and stuff like that about all the ideas and requests that you have. Thank you.